Hey Andrika, I'm just going to do a quick video for you of one of the problems. This is problem 525 in section 5.1.3 using inverse trigonometry. So that's going backwards. When we know all the side lengths but we actually want to find the angle, there's a way we can do that with our calculators. So in this situation we've got a right triangle, and again this only works for right triangles. I'll label it ABC. We're told its hypotenuse is 15 and the base is 14. Now you could calculate the height. We don't need that because what we really want to calculate for this problem, we want to know what is the angle of this right triangle. Now we know that we are looking at two side lengths for angle theta. We have an adjacent side length and the hypotenuse. And so when we, whoops, this one's the hypotenuse. And this one's adjacent. We know that cosine of theta, we don't know what theta is, but if we knew, we would take the cosine of that angle and it would give us the adjacent side length over the hypotenuse. So this is the equation we're trying to solve. Normally, we know this angle and we just have a missing piece of information in the ratio and we solve that ratio. So now we're going to go backwards, and that's where we introduce this idea of an inverse or backwards trig function. Okay, so if the cosine of theta is equal to 14/15, we can rewrite this and say the inverse cosine of the ratio equals theta. Okay, now this kind of looks like an exponent, like a negative exponent. That is not what this is. Okay, this is not an exponent. This means inverse cosine. Okay, it means going backwards. So starting with the ratio of adjacent over hypotenuse and going backwards to get theta. Okay, so this is the setup for the equation. This is how I rewrite the equation and what I'm going to type on my calculator. Now, on our calculators at school, this inverse cosine button is the same button as cosine. You just have to hit second cosine. So this one would be the second button, and then cosine to get inverse cosine. Now, I'm not sure what calculator you have with you. If you're using a cell phone calculator, I don't believe these have an inverse trig function option. So then you'll probably want to go on the Desmos website and use a Desmos calculator. Oops. Okay, it's called inverse cosine. Another way they will write it sometimes on online calculators is arc cosine. I don't know why. I'm sure there's a really good reason, but I don't know what it is right now. So inverse cosine, arc cosine, it's going backwards, starting with the ratio, going backwards to get theta. So if you just type in inverse cosine of 14/15 on your calculator, okay, the ratio stays the same. We don't flip the ratio. This is not an exponent. We can get what theta is. So if I plug that into my calculator, it tells me that theta is approximately 21 degrees. Okay, and then I can get the rest of the angles. If I cared about those, I could find this other angle. But if I'm just trying to find theta, it's approximately 21 degrees, and I would get that by typing second cosine 14/15 equals, and then it would say 21 degrees-ish. Okay, and this also works for if we're looking at, let's say we had a different triangle. Okay. Let's say that we had theta, but this time we were given the height and the base. Okay. We would calculate theta by finding, instead of finding tangent, where this is opposite over adjacent, we would find inverse tangent and type that into our calculator. Okay, we can also find inverse sine. Okay, so make a whole new triangle. So if I say like this is 12 and this is, I don't know, 4, we could calculate the missing theta by taking the inverse sine, opposite over hypotenuse, and that would give us theta. To get to each one of these, you just hit the second button. So this you would type in second tangent 5/10, second sine 4/12. Or if you're using a calculator, it might say arctan of 5/10 and arc sine. Okay, so these are exact answers, and then you would approximate it with your calculator. Okay, the other big thing that we learned was, oh my gosh, how do you keep track and remember when you're using cosine, tangent, sine? Because there's a lot of ratios to keep track of. What if you flip the ratios? That was the most common mistake students were making. Okay, and that's where we introduced this idea of SOHCAHTOA. So if you've ever heard that phrase, okay, what it's talking about is a way to keep track of which trig function goes with which side lengths and in which order. Okay. So SOH, this is for sine, this is for cosine, this is for tangent. Okay, so sine uses the opposite and the hypotenuse side lengths, and it's in that order, opposite over hypotenuse. Cosine uses adjacent over hypotenuse. Tangent uses opposite over adjacent. So it just tells you which trig function, which side lengths, and what order. So it's numerator over denominator, numerator over denominator, numerator over denominator. Now you know what SOHCAHTOA is and how to use it. This is SOHCAHTOA for which side lengths to use. Up here was talking about inverse sine, inverse cosine, and inverse tangent when you know the side lengths but wish you knew the angle.